Hello, in this video, we're going to be looking at lesson 10.7 on finding the volume of pyramids and cones. The essential question that we'll answer is how do we find the volume of pyramids and cones? Let's start with pyramids. The volume of a pyramid is related to the volume of a prism with the same base and the same height. In class, we looked at a demonstration that showed that it takes 3 pyramids to fill a prism with the same base and the same height. So if we calculate the volume of a prism with volume equals the area of the base times the height, for a pyramid, we just need to divide that by 3. The volume of a pyramid is 1/3 the volume of a prism with the same base and height. For the capital B, you'll need to use the appropriate area formula for the base depending on what shape it is. And the height of the pyramid is different from the slant height that we used in lesson 10.6. The height of the pyramid is the distance from the vertex to the base. Recall that the slant height is the height of one of the triangular lateral faces. So this piece right here is the slant height. For the volume of a pyramid, we need the height. The formula for volume works for right pyramids, which are the most common, as well as oblique pyramids like this one. Let's try an example here. We're going to find the volume of the pyramid, and if necessary, we'll round the final answer to the nearest tenth. The first thing you need to do with a pyramid is identify the base, because we need to find the area of the base. And most of the time, the pyramid's going to be sitting on its base. Recall that the vertex is the point where the triangular lateral faces come together. Usually it's the top, but I guess technically the pyramid could be laying on its side or be upside down or something. And since our base here is a triangle, we need to use the formula for the area of a triangle, which is area equals base times height divided by 2. Now, it might help us if we just draw out the triangle. You'll notice that this is a right triangle and the sides are 3, 4, and then the hypotenuse that's across from the 90 is 5. When we find the base and the height in a triangle, they need to be perpendicular to each other. So we're going to have to use the 4 and the 3. So we'll do 4 times 3 divided by 2. That's 12 divided by 2, which is 6. So our base has an area of 6 square feet. Now you can see that the height of the pyramid is that 6 feet right there, the distance from the vertex to the base, 6 feet. And now we have everything we need to calculate the volume. Volume of a pyramid is the area of its base times its height divided by 3. So here that's going to be 6 times 6 divided by 3. And that ends up being 36 divided by 3, which is 12. So our volume is 12 cubic feet. Remember that volume is 3-dimensional. It's how much space it would take if we were to fill the pyramid. So your volume is always going to be the unit cubed. Here's another example of a different pyramid. This time you'll notice that the base is a rectangle. So when we calculate the area of this base, since it's a rectangle, we'll have to use our rectangle formula. Area equals base times height. Notice that both sides are 6, and 6 times 6 is 36. So the area of our base would be 36 square inches. You can see the height of the pyramid is labeled right there. It's 3 inches. And now we can find the volume. Area of the base times the height divided by 3. So that's 36 times 3 divided by 3. Now notice that there's a times 3 and a divide by 3. Those are inverse operations. 3 divided by 3 makes 1. So that actually just cancels out and we're left with 36, meaning the volume of this square pyramid is 36 cubic inches. Here's one more example of a pyramid. You can see that this pyramid has a regular polygon as its base. In this case, it's a hexagon. I'd like you to try this one on your own. Pause the video, and then when you hit play, the solution will be posted. Here is your solution. The area of the base Apothem times perimeter divided by 2, you'll end up with 165.6. The height is 9 feet, and then plugging those values into the volume equation, you should have ended up with 496.8 cubic feet. Now that we know how to find the volume of a pyramid, we're going to look at how to find the volume of a cone. And cones and pyramids actually behave the exact same way. The volume of a cone is also the area of the base times the height divided by 3. But since our base is a circle, we know that the area formula for a circle is always pi r squared. So we can be a little more specific for the volume of a cone. Pi r squared, that's the area of the base, times the height, divided by 3, where r is the radius of the circular base and h is the height. Once again, the height of the cone, it's not the same as the slant height that we used when we did surface area. The slant height would be from the vertex to the edge of the circular base. When we do the height, we're looking for the distance between the vertex and the base. So you'll look for that 90-degree angle mark. Let's try an example here, and we're going to write our answer in 2 different ways here. First, we'll write it in terms of pi, and then we'll round to the nearest tenth by using the pi button on our calculators. You can see in this cone, the radius is 10 centimeters, and the height is 20 centimeters. I'm going to write down my volume equation. Volume equals pi r squared times h divided by 3. And then let's put our values in there. So we have pi times 10 squared times 20 all over 3. And then order of operations says we square the 10 first before we multiply by 20. So 10 squared is 100. 100 times 20, and then don't lose your pi. Pi is still in the answer. So 100 times 20 pi all over 3 is 2,000 pi over 3. Now at this point, when I want to leave my answer in terms of pi, I could either leave it like that, or if I use my calculator and divide this out, 2,000 divided by 3 is 666.6 repeating. So 666 and 2/3. So I would accept the answer as either the repeating decimal, like I wrote there, 666.6 repeating pi cubic centimeters, or you could leave it as 2,000 pi over 3. That would be the same thing. Then to get the approximate answer, we need to use our calculators. So on the calculator, what you're going to type in is 2,000, then click the pi button, and then divide button 3. And the calculator will do the whole thing for you. When you stick that into your calculator, it's 2,094.39, keeps going. I want to round to the tenths place, so I'm going to round up. So we'll say the volume is approximately 2,094.4 cubic centimeters. And there's our answer expressed, well, I guess 3 ways. These 2 are the same exact answers, and then my approximate answer with that approximate symbol. Now, sometimes when you're trying to find the volume of a cone, you might not be given the height. You can see in this problem right here, we're given the slant height is 10. We need the height in order to find the volume. So I'm going to draw the height in the middle of my cone here, and let's label that with an H. You can see too that the diameter of the circle is 12 meters. Notice that goes all the way across. For the radius, I need half of that. So 12 divided by 2 is 6. And what I just formed here is a right triangle with sides that are 6, h, and 10. We know that in a right triangle, a squared plus b squared equals c squared. And the c value has to be the hypotenuse, which here is that 10. So I'm going to go 6 squared plus h squared equals 10 squared. We'll do our Pythagorean theorem like we've been practicing for the last several months. And I'm going to get my h squared alone by subtracting 36 on each side. H squared is 64. To undo the squared, we'll square root. That's the inverse operation of squared. Now we have H equals 8, and that's everything we need to calculate the volume. Our radius is 6, our height is 8. So if we use our volume equation, pi r squared h divided by 3, that's going to be pi times 6 squared times 8 divided by 3. And when you type that in, you're going to take 6 squared times 8, which is 36 times 8, 288, and 288 pi divided by 3. Again, I want to leave the pi in my answer until the very end when I round. So I'm going to take 288 and divide that by 3, and that is 96. So our volume, the exact volume, is 96 pi cubic meters. For the approximate, just put 96 pi into your calculator, and you'll end up with the approximate value from the calculator, 301.6 cubic meters. Here's one final example. In this cone, once again, we have the slant height and we need the height. So just like the previous problem, we can set up the Pythagorean theorem, h squared plus 16 squared equals 34 squared. Use your calculator to square those values. And then I will subtract 256 on each side to get h squared alone. So now h squared is equal to 900. Take the square root of 900, and we'll have the height equal to 30. So our height is 30. The radius was given as 16. And now we can apply our volume equation. Pi r squared times h divided by 3. So here, that's pi times 16 squared times 30 divided by 3. And when we type that in our calculator, you can do 16 squared times 30 all kind of in one calculation. And that is 7,680 pi over 3. I'm going to divide that by 3. It divides evenly, so we have 2,560 pi for our exact volume. And that would be cubic centimeters. Now for the approximate, just go ahead and type 2,560 pi button into your calculator. And when you do that, it'll give you approximately 8,042.5. So we've now practiced finding the volume of pyramids as well as the volume of cones. Thanks for watching this video, and good luck as you practice some pyramids and cones on your own. Bye.